So we in the previous class discussed about retransmission timer management because we were discussing the congestion control in TCP, how the TCP manages the managing the congestion. Okay, so in that there are two components. One is a timer management, another is basically the window management, retransmission timer management, and the window management. Because if you do not select a proper timeout for a sender, okay, if its value is too small, there will be more retransmissions, and if its value is very high, okay, there will be delay in delivering the segments to the application, okay, to the TCP user. So so obviously whenever the congestion rises in the network, okay, obviously this when the congestion is there in the network, there will be the delay will increase, the transit time in the network will increase. Hence you have to modify your retransmission timer value, because acknowledgement will get delayed, because since the transit time increases, the segment will be there will be time in delivering the segment at the receiver end, and acknowledgement of that particular segment, positive acknowledgement of that segment will take time to reach at the sender. So since because of the increase in the transit time, if you do not increase it, so the important, the vital element is just the retransmission timer. Okay, what should be the value of the retransmission timer in managing the congestion? Because if the retransmission timer value is not managed properly, what will happen? There will be timeouts. The senders will retransmit their segments again. They will dump their segments again onto the network, and finally congestion, it will further congest the network, right? Another component that is very vital in managing the congestion at the TCP level is that window management. So in window management, we say, like I told you, that the amount of credit allocated to the sender from the receiver end, right? So receiver visualizes the current buffer capacity that it has. Okay, I told you that there can be a static and it can be a dynamic one. I have given you an example of a hotel, right? Hotel room where the manager feels that only this conservative approach, where the manager will allot rooms only when they are vacant. Okay, he will not take care of that this room may get vacant in the next day or by that time when the guests are supposed to come. So there can be another approach that can be dynamic approach, where the receiver can allocate buffer space in considering the future, like anticipating the future, right? Anticipating that the maybe more buffer space will be there. So it allocates more. So another component that is very vital in managing congestion is the window management, right? So window can be controlled by this, how much credit you are assigning to the sender. So there are two vital elements. So we discussed retransmission timer management, that what should be the way to decide the value of a retransmission timer. So one is like you cannot take only the previous instance, the last segment. You cannot take the transit time of the last segment which was transmitted and received the acknowledgement. That may reflect the actual picture, that may not reflect the actual picture of the network, right? Because at that time the network is free. Okay, the congestion had just begun to the network had just begun to congest, while since the congestion is dynamic in nature, the network may congest anytime. So so you cannot, so what should be the way to decide, right? So we can take the simple average of all the previous instances, that is called as a simple average, but in that, when we take the simple average, we give equal weightage to all the instances rather than putting higher weightage to the most recent instances, because the most recent instances will say the actual condition of the network. So rather than what we do in simple averaging, we give equal weightage to everyone. Okay, so if there are n number of segments transmitted, and we are seeing the transit time of each segment. Okay, to calculate the n+1 segments time. So and if we taking a simple average means what? We are giving the equal weightage to all the instances for n segments. But actually, the older segments may not reflect the actual condition of the present condition of the network, right? That will be reflected only by the very recent one. So simple average doesn't solve. So what we do exponential averaging, where we assign more weightage to the most recent one as compared to less weightages to the older ones. Okay. So that is basically we do in the exponential averaging in finding out the retransmission timer value. Okay. But this also doesn't solve the issue. So basically there is a retransmission timer variance, right? Round trip time variance estimation proposed by Jacobson, that we take out the variance in the round trip times, how much they are deviating from the average value. So that we take it. So that is what the algorithm proposed by the Jacobson. So we did these things in the previous class, right? Now, and we also discussed that the Kahn's algorithm, that why this Jacobson failed to answer that what should be the retransmission timer value for a retransmitted segment. So it was answered by the Kahn's that there should be an exponential backup should be used, that every time a segment is retransmitted, okay, RTO value will be calculated based on this formula. Okay, Q is 2. Next time, if it is once again retransmitted, Q value will be 4, right? So it will exponential increase. So if a segment is dropped, right? So why it is done like that? Why there should be an exponential backup? Because suppose you are doing multiplexing, there are n number of TCP users, right? And through this multiplexing, and this got dropped. Okay, no acknowledgement came. So n number of users which transmitted segments will once again retransmit at the same time if we use the same retransmission timer. So again, the load on the network will be more. Okay, congestion will further increase. So, so what should be the way? So every user should retransmit at a different time, not at the same time. So how will they be? How they will different? Means there should be some differing. They should differ in transmission. So when they should transmit, that should be differentiated by a exponential backup time. So some station, some user will transmit at a particular time, the other will transmit at a different time, because this Q value will be different for each user. So that is what that will save the chances of congestion. Okay. So for each retransmitted segment, there should be a exponential backup should be used, and which sample should be given to the algorithm for calculating the variance. So that is what I explained to you, that some segment is transmitted here. Okay, and the sender gets timed out. It doesn't receive any acknowledgement. It gets timed out and retransmitted the segment, and immediately after that it receives the acknowledgement, right? So now which one should be taken as a sample to, which one should be taken as a time for the retransmission timer value for this Jacobson algorithm? So which sample should be taken? Because this can be, if this is the acknowledgement of this, okay, so that means if the sender presumes that this is the acknowledgement of the retransmitted segment, okay, while actually it is from the while it is the acknowledgement of the original segment, then what will happen? Based on this, if it selects the retransmission timer value, this value will be very less, right? And it will result in more number of retransmissions. You following? Or it can be otherwise also. If this is the acknowledgement it has received, and if it presumes that this is an acknowledgement of the original segment, okay, while actually it is for the retransmitted one, then also the time that it has calculated, this will be very large, right? It will create unnecessary delay in the transmission to the TCP user, right? Delivery to the TCP user. So this, so which one should be fed back? So what Khan suggested that do not measure the RTT for the retransmitted segment. Calculate back off whenever retransmission occurs, and keep use back off RTO until acknowledgement arrives for the segment that has not been retransmitted. Once a positive acknowledgement receives from the other end, then only you should calculate the RTT value. Otherwise, don't calculate the RTT value. Rather, you continue with the back off scheme. So that is what the Khan suggested, right? So this is what we did in the previous class. Just I reviewed it. Any doubt so far? Any doubt? Yes. Any doubt? Ayush, is there any doubt?
No, sir. Am I audible?
Yeah, you are audible. So next is window management. There are two ways for window management. One is called as a slow start. Though it is a misnomer that it is not a slow start. Actually, hota kya hai? Like once a credit is allocated to the sender. Okay, suppose you have said that the 1000 octet. Like if you remember the sliding window protocol, right, for flow control, what exactly it was? That if you have selected a window of 7, what exactly it means? Huh? The sliding window protocol, if you have a window size of 7, what exactly it means?
There are 7 frames.
Right? The sender is free to send 7 segments, 7 frames, okay, without waiting for the acknowledgement. That was the window policy. That was the sliding window protocol. So you keep a window of 7. That means sender can send 7 frames at a time without waiting for the acknowledgement. Right? It can exhaust the complete window, whatever is allocated. Similarly, here also, like I told you, that is the credit scheme. Okay, there is a credit scheme. Like some credit is assigned to the sender. Okay, so what happens exactly? That suppose if a credit is given for J octets. Okay, so that means sender is free, because once a connection is established, okay, initially the connection establishment process will be there, and once the connection is put in the established state, what will happen? The sender, I'm telling you why it has been named as slow start. Why it has been named as slow start? Okay, because once you have given a credit of J octets to the sender, sender may dump J octets of data on the network immediately. Okay, so that will, what will happen? This will create a congestion, right? This will congest the network. So just to avoid that the sender should not dump the entire credit onto the network. Okay, it is expected that the sender should behave in a proper way, like it should start slowly rather than dumping the entire credit on the network. It should start slowly. It should start sending only smaller segments of data, and then it should increase. Okay, so so it was suggested like that. So what was suggested, that larger window, that whatever, suppose if your J octets has been given, suppose if I am saying that the receiver has given granted a credit of 1000 octets to the sender. Sender may immediately dump 1000 octets without waiting for any acknowledgement, right? So if it completely dump the entire thing, okay, the network response will be slow, and subsequently what will happen? Some of the segments, because it will get delayed, because once you dump entire data on the network, it will get delayed. Okay, senders may timed out, may again do the same thing. So just to avoid this thing, what is suggested that the sender should start with a slower manner. So what it is like that there is a allowed window is defined. Okay, AWND allowed window size, that how much it is allowed to dump. Okay, on the network when a connection starts. Okay, at the beginning of a connection, how much it can dump. Okay, if the credit is assigned as J, okay, if the J octets of credit is given to the sender, out of that, how much it should be allowed to dump in the beginning of the connection. So what should be the allowed window? That, and this is what it should be: minimum of credit, comma, congestion window. So congestion window is initially set to 1. Okay, congestion window is initially set to 1, and credit is of J octets. So obviously the sender will send only one segment in the beginning. Okay, so it sends the first segment, it gets acknowledgement of that. Okay,
Excuse me, sir.
yes.
Sir, are you sharing the screen? It is not visible.
Yeah, I'm sharing. इतना देर से तुम नहीं बोल रहे हो, इतना बता दिए हम. अभी दिख रहा है?
Yes, sir.
So what I am saying, that what is the meaning of a slow start? This is called as allowed window. Okay, allowed window is what? The minimum of credit J octets and congestion window 1. Congestion window is defined as 1. Okay, that depending on the congestion in the network. So since the connection is just established, so congestion window is set to 1. Okay, and this is what the credit of J octets. So the minimum of that is always 1. So initially the sender is allowed to send. See why it is called slow start. That is, you should understand why it is called as a slow start, because suppose it will start with the sequence number 1001. So it will come with an acknowledgement of, suppose if it is 200 octets of data. Okay, AN201, right? So it is acknowledged, or you can say, so it is acknowledged ASN 1001 if there is a 200 octets in a segment. So AN 1201 means what? The segment 1001 is, the sequence number 1001 is acknowledged, right? So are you following why it is called slow start? Because the sender may dump the entire credit on the network. That may slow down the things and may result in more retransmission. So to avoid that, we select an allowed window for the sender, that the sender should start in a gradual manner, not in the entire credit it should dump. So it should start its window, expand its window gradually, right? So we take a minimum of credit and congestion window. So this congestion window will be defined on the based on the congestion in the network. So initially, suppose if it is 1, so credit is, so the sender is allowed to send only one segment out of the credit given. Okay, and once this segment is acknowledged, okay, then it is allowed to send 2 segments. And once it receives acknowledgement for both the segments, okay, it sends, next time it sends 4 segments. Okay, then it receives an acknowledgement of 4 segments. Okay, it sends 8 segments, right? So it basically exponentially increases. So this is basically slow start is just a misnomer because here it is not going slowly. What is it is happening? It is starting gradually. Okay, then because what is happening? It's sending one, then one acknowledgement. One acknowledgement means it can send two segments. Both the segments are acknowledged, then it is allowed to send 4 segments. When all the 4 segments are acknowledged, it will send 8 segments. So gradually its window is gradually, I should not say exponentially, the window will increase. Okay, depending on the credit given. Followed. So this slow start, if you see what happens, it starts with like this. This is the congestion window. So it starts slowly, but it rises exponentially, right? It rises exponentially. So slow start. Are you following? What is the meaning of slow start? So increases when data acknowledges and it exponential growth. So it increases, the window increases exponentially. So what happens at a time? Once the window will increases exponentially, so what will be the result? There will be more timeouts and more retransmissions. Okay, and this is not a justified management for the window, though it is slow start. It is named slow start because just to allow the sender only to increase its window gradually, but it is not gradually, it is increasing exponentially, right? So if it increases exponentially, what will happen? There are more chances that most of the segments will be dropped and they will be further retransmitted and will further congest the network, right? So what should be the way to do it? The way is that dynamic window sizing on congestion. What is that? So whenever a timeout occurs, maybe due to the congestion, okay, due to the congestion, what we do basically, we start slow start, okay. So we start slowly, we start gradually, okay. So we set some threshold, okay. We set some threshold value. This threshold value is called slow start threshold. It is kept as congestion window by 2. Okay, so you can see it has occurred at this time. So we have defined this congestion window to half of this. Okay, this threshold we have decided. So initially what happens, we start with slow start. Okay, we start with slow start means what? The sender sends one segment, it gets acknowledged. Okay, then it sends 2. So initially it follows the slow start till it reaches to this threshold value. Okay, that is what the exponential one. Once it will send one segment. Once it is acknowledged, it will send 2 segments. Then once it is acknowledged, okay, once it is acknowledged, 2 segments are acknowledged, it will send 4 segments. Then 4 are acknowledged, it will send 8 segments. So till this threshold value is reached. That threshold value is defined as congestion window by 2. So how this is defined? When the timeout occurs, this congestion window is half of this. The threshold is set as half of this congestion window, right? So this slow start will continue till this HS threshold is reached. Once this threshold is reached, there will be a gradual increase. एक भेजेगा, एक acknowledgement आएगा, then it will send another one. Then it is acknowledged, then it will send another one. So this will be a gradual increase. gradually, and here it is slow start, or you can say exponential, right? This one. Why we are going on dynamic sizing? What is the advantage of dynamic sizing? That this situation will not come. What was this has happened in case of a slow start, which is just named as slow start, but the window is expanding. Window is expanded in an exponential manner, right? Because it sends one segment, acknowledged, sends two segment, acknowledged, four segments, four acknowledged, eight segment, eight acknowledged, like that, then 16, 32, 64, 128, like that. And finally one, so it is an exponential increase. And what will happen because of that? If timeout occurs, right? Because the congestion will increase because of an exponential increase in the window. Sender is too aggressive. Okay, receiver may not keep pace with that. Routers may have to drop the segments, right? So, so just to avoid that, what should be the other way? The other way is that we have to start with slow start, because the sender should not be allowed to dump the entire credit on the network once the connection is established. So we will begin with the slow start process. So how long we will go with the slow start? We define a threshold. This threshold is equivalent to half of the congestion window, right? This threshold is set to half of the congestion window, and till then we follow the slow start process. And after that, once we reach this threshold value, there will be a gradual increase, okay, in the window size. Sender will send one segment. Once it is acknowledged, it will send two, another one, then one. So it will be a gradual increase. Every time one segment it will send, right? So that is what the dynamic sizing. So when a timeout occurs, perhaps due to congestion, set slow start threshold to half of current with congestion window, set window to 1, and slow start until threshold. So we slow start until threshold. Beyond threshold, increase window by 1 for each RTT, each round trip time. Okay, so like that. So this is what called as a dynamic sizing on congestion. So in this way, the window management is performed, okay, to avoid congestion in the network. So there are two components in congestion control. One is a retransmission timer management. So we have seen that there are different ways to do it, okay. And in window management, there are two ways: slow start and dynamic sizing on window. So this is you can see here that threshold is capped as 16. Okay, this is a congestion window. So this is a slow start. Okay, एक भेजा, फिर दो भेजा, फिर चार भेजा, like that, and it goes exponentially to this. This is a threshold, and then it goes, timeout occurs. Then this is what additive increase. Once it is reached threshold, it is 1, 1, 1, 1, like that. Okay. And this is what the multiplicative decrease. So slow start, then AI, like that. That is what the TCP congestion control. So what is the difference between flow control and congestion control? So flow control basically prevent receiver buffer overflow. Congestion control avoids congestion. It finds out what are the reasons that it should avoid congestion. Receiver based flow control is always receiver based. Okay, like you remember the choke packet and other things. So always the receiver has some tactic to control the flow, right? It is network based. The congestion is network based. So we have a congestion window. So sender's window is minimum of congestion window and the received window. So received window is what? that the credit flow control scheme is what? The credit based flow control scheme. So whatever credit is assigned, you can say the credit or the received window size or the credit assigned, at the same thing. Now the last thing is that in a user datagram protocol, is there any doubt in this? In the congestion control, is there any doubt?
No, sir, understood.
Then, as I told that TCP at the transport layer, we have two protocols. One is called as a TCP, transmission control protocol, that is basically a connection oriented one. Okay, and we also have a connectionless protocol, that is user datagram protocol. As you are well aware that connection establishment, there is always an overhead in connection establishment, right? And suppose for many applications where a connection establishment process is undesirable. Undesirable means where we are not going to have a long dialogue or suppose long sequence of data. Okay, establishment of a connection will be an overhead. So for only a small chunk of data, or we can say the busty data, can be well handled by this user datagram protocol, which has no overhead issue. Right, so it's a connectionless protocol. Okay, and though since it is connectionless as compared to TCP, it is unreliable, right? But it can be used for many applications, right? Request responses, like you receive bank transaction messages, right? Whenever you perform any transaction, you receive some messages from the bank side. So there we use UDP. Okay, and so many real-time applications involve data collection, like you have some sensor data to be collected, right? Where suppose you want to measure the temperature sensor data. Okay, so every 1 hour you are sampling. The sample is sent at an hour. Okay, so at an interval of 1 hour, you will be sending the samples. So suppose if the process is not very critical, right? If you lose 1 or 2 segments, 1 or 2 samples will not make a much difference. Suppose if I'm measuring a room temperature, right? So room temperature is not going to be drastically changed if I miss 1 or 2 samples, because the subsequent samples will update it, right? So in such process, right, outward data dissemination, like you want to disseminate some kind of a news, right, or to a mass. So in such scenarios, we can use this UDP, right? So that if some messages are missed also, it doesn't matter. So at the same time, it is unreliable, and delivery and duplication control is not guaranteed. No guarantee for delivery, no guarantee for duplication. Because why it is so? Because it extracts the service of IP, Internet Protocol. All the UDP data is constructed in an IP datagram and sent over the network, right? So basically UDP passes down the things to the IP encapsulate all the things in an IP header and then pass it on in the network. So IP is also unreliable. IP also doesn't guarantee. Okay, no guarantee for duplicate detection, no guarantee for delivery. So IP is also unreliable. But since though it is unreliable, but it reduces the overhead of connection establishment, right? So it is well suited for applications where we are not having very large amount of data to exchange. Okay, the users are busty in nature. Okay, sometimes they have data, sometimes they have no data. So, so this is used for many such applications, right? This share bazaar, right? You get updates. So UDP is well suited for these applications. Okay. So this is what a UDP header looks like. So we have a source port, we have a destination port, port address to identify a process on an end user. Okay, from where it is originated, where it is to be delivered, destination port, length of the total data, checksum, right? And then the entire thing is passed down to the IP, where it gets encapsulated in an IP header, right? So this is what another thing, that is TCP also uses the services of IP, right? So I must say that how it maintains that, how it avoids that there is a pseudo header. There is a pseudo header. So TCP includes this pseudo header, right? What is the need of this pseudo header? What exactly the TCP does in a segment? Okay, it includes the TCP header, and then after doing that, it also encapsulated into a pseudo header. What is this pseudo header? Basically, this prevents misdelivery by IP, because as you know, the IP is unreliable. So once the TCP uses the services of IP, it knows that the IP is unreliable, IP may perform misdelivery. So just to save itself from the misdelivery, it encapsulates it into a pseudo header. So this pseudo header basically includes a duplicate, what will be the IP address of the source, IP destination address, and what is the source port, destination port. So all those things are duplicated over here in the pseudo header. So if the TCP, just to cross check when the data is delivered at the port, how the TCP will ensure that the delivery is done. So for that, it puts a pseudo header to cross check it whether the IP has done it correctly or not, right? So there is one pseudo header is added, right? So this finishes the third module. Can we have a quiz tomorrow for this third module? Hello, can we have a quiz tomorrow? Akash. Akash Kumar.
Yes, sir.
पहली बार आए हो ना आज?
Yes, sir.
You are coming first time to the class.
No, sir. मैं अभी VIT मोड जा रहा था. ये मैं फोन में कुछ इशू आ रहा था. ये फोन की स्क्रीन निकली उसके लिए. मैं क्लास कुछ सुना नहीं आज.
I am seeing you first time because I find out who all are attending the classes, right? I did an exercise and find out how out of 56, every time very few students are joining. If I did an exercise and find out that who all are coming, so accordingly I will also provide the treatment. No, that if I have to give some marks or something to students, I will only give to those who have attended the classes thoroughly. So please don't expect that if you are not present or in the coming classes, if you are present, okay, I will see that, right? But definitely those who are attending from the beginning, they will get a higher share of marks. That is very true, right? So, so I will see all those things if I get an opportunity to do that, right? Presently, I'm not saying about the attendance. Attendance carries no marks. Okay, I'm not saying attendance, but I did an exercise to see how many students are joining and why they are, who all are there, who are not joining, right? So just please send this message to everyone that I have made a list. I have a list who all are active, who all are inactive, right? So I can, yes, Ayush.
Sir, from 6 p.m. it will be okay tomorrow. We have a quiz from 7 p.m. tomorrow.
I am not in a hurry, right? If you say you want to give day after tomorrow, that will be also fine, right? I'm not in a hurry. पढ़ लो तुम, ठीक है? So, or if you are okay with tomorrow 6 p.m, I can take it at 6 p.m. As you say. Ahsan?
Yes, the day after tomorrow will be good.
Yes, sir, parcel.
Okay then. So day after tomorrow 6 p.m. Okay.
Yes, sir.
Okay then. And there are two things I want to say that there is a module 4 and module 5, right? In module 4 we will study in more about the network security side, okay, and module 5 is based on the applications like the HTTP, SMTP, simple mail transfer protocol, HTTP hypertext transfer protocol, SNMP, simple network management protocol. So all those application layer protocols are there in the last module, right? In the fourth module, we have this network security. Okay. So which one I should start? What if you have any suggestion? I can start that module because the last module is bit smaller. I can say though contents are large, but it can be finished quickly. Right, but the fourth module will take some time if you really want to have an understanding in that because it is very good. You may require it also because security part. Anywhere you are using this cyber security, so it can be useful for you. So we can study it in a bit detail, right? So which module I should start, fourth or fifth?
Sir, whichever is more important for end semesters.
Important for what? Exam point of view or for
exam
your
end semester?
End semester. Okay. I'll start with module 5 first, and then when we will do module 4, right?
Okay, sir.
Okay. Thank you.